When working with image stacks in 3D Slicer, there are a few important steps we need to take to make sure all of Slicer's tools and analysis features work correctly with the dataset. An image stack is simply a sequence of 2D images, such as TIFF, PNG, or JPEG files that together represent a 3D volume. You can think of it like slices of bread forming a loaf. Each image is one slice, and when they are stacked in the right order, they create a complete 3D dataset. There are two key things to keep in mind. First, unlike medical imaging formats such as DICOM, image stacks usually don't contain spatial metadata. Information like voxel size or slice spacing isn't stored in the files, which means we need to define it ourselves. And this step is crucial if we want accurate measurements and reliable volume calculations. Second, image stacks are often loaded as vector volumes. This happens because formats like PNG or TIFF can store multiple color channels per pixel. So Slicer interprets each voxel as having several values instead of a single intensity. However, most tools in 3D Slicer are designed to work with single channel data. So we will need to correct this before moving forward. Let's get started. I have a micro CT scan of a tooth with a voxel resolution of 15.9 microns, and it is saved as a bitmap image stack. To load the data, I can either click the data button in the toolbar here, or use the add data button in the welcome module. In the window that pops up, we can either choose a directory to add or select files. I usually prefer selecting the entire folder, navigating to my dataset and clicking select folder. Before loading, I always double check that all files will be imported. By clicking show options, I make sure single file is not checked because otherwise only one slice would be loaded. Then I click OK, and now the dataset is loaded into 3D Slicer. As a first step, I like to turn on the crosshairs because it helps me understand the position of each slice across the views. To quickly check how the dataset was loaded, hover your mouse over any slice view and look at the data probe panel. If you see three numbers, the data is loaded as a vector volume. This means each voxel contains multiple values, and some tools may not work correctly. So we need to convert it to a scalar volume, where each voxel has a single intensity value. From the module drop-down menu, I'll go to Converters and select Vector to Scalar Volume module. Make sure the input volume is selected correctly, then create a new output volume. I'll name it molar underline scalar. And click Apply. Now we see the new scalar dataset is loaded, and when I hover over the slice view, I see only one number per voxel, which confirms the volume is now scalar. Next, we correct the voxel size. I need to go to the Volumes module and select my newly created scalar volume. Under Volume Information, we have the image spacing, which technically represents the voxel size. By default, it is set to 1 millimeter, which is not correct for this dataset. Since 3D Slicer uses millimeters as the default unit, we convert our value accordingly. I enter 0.0159 millimeters, which is my scan resolution. And because micro CT scans are normally isotropic, meaning the spacing is the same in X, Y, and Z direction, I will copy this value into other dimensions. The volume disappears from the views, but no worries. Just click the center buttons and it will come back into view. You can also confirm here that the volume type is scalar, which we set earlier. As a final step, I recommend saving the corrected volume, so all settings are preserved. To do so, we go to the Data module, right-click the scalar volume, and choose Export to File. Save it as NRRD because this format keeps the voxel spacing and metadata. Next time you open it, it will load ready for analysis. And that's it for this video. Thank you for watching, and if you found it helpful, don't forget to like and subscribe.